welcome to the online physics class. I am your online physics tutor bedprakash. So let's learn about fluid mechanics in my class for class 11 as well as for joint entrance. So let's learn. In my today's session, I will be discussing about the fluid dynamics. Till date, we have already discussed about the statics of the fluids. Now, from now on, we will be discussing about the different dynamics of fluid. So, whenever we are talking about the dynamics of fluid, that is, we are interested to know about the different dynamic characteristics of fluid when it flows through a medium. Normally, it flows through a pipe or any kind of different flowing devices or different instruments like that. So we have to consider that a flow of fluid when it is in dynamic in nature. So what kind of flow? Basically, we separate the flow in two types. One is steady flow and another is unsteady flow. So in broad sense, you can see in the presentation that it has been termed as streamline flow, or to be very specific, it is sometimes termed as laminar flow and turbulent flow. There is certain limit of flowing or certain characteristics of flowing where the fluid maintains its steadiness. Now, how a fluid maintains its steadiness? Let's see this. First, you have to know the 2 points. One is steady flow, and this is termed as when the fluid, consider a fluid pipe like this having different cross-sectional area. Now the fluid is, let's say, it is flowing in this direction and it is getting out from this direction. Now at this initial point, the fluid is, say, point A. The fluid is having velocity of A. I am giving the vector sign since it has a particular direction along its magnitude. It is achieving a velocity of VA at the point A, and after traveling along this line, after some time, it achieves a velocity along this point, say B, say VB. Now after certain time, like in this manner, it achieves a velocity of VC at the point C, and in this manner at the outlet it achieves a velocity of Vd at the point, say D. Now the thing is that with the passage of time, now let's see the time difference in these 2 points. Let's say the time difference is delta t. In this time window, in this particular time window, the fluid is achieving the velocity from Va to Vv. Now if the velocity of the fluid with change of time remain constant in nature, if the velocity is constant in nature, then we will term the fluid as steady flow. But with the time or the velocity of the fluid is getting changed, then we will term as unsteady flow. That is, in the case of unsteady flow, the velocity of the fluid will get increased depending on certain other circumstances. There is a term called streamline. It is a very interesting and important term to understand to solve different numericals, that this is basically the path along which the fluid flows. Streamline is basically the path that may be a straight line, maybe a curve, along which the fluid is flowing through it. So in this particular representation, this is the streamline of the fluid. Now you can see there are two types of flow of fluid has been mentioned. That is, one is streamline flow or laminar flow, and another is turbulent flow. Now, in case of laminar flow, when there are several layers of fluid or several steps of fluid which are flowing with constant velocity, without, that is steady in nature. The fluid is quite steady in nature with a regular uniform velocity. It is flowing throughout its flowing area. Then it is termed as laminar flow or streamline flow. When the case arises that the fluid exhibits some irregular behavior or some disturbing behavior along its line of flow, that is, it changes its velocity along its position with the time, then the nature of the flow of the fluid is termed as turbulent flow. From this particular discussion, we can conclude that uh, the velocity of the fluid is basically the fluid particle position function, that is change of fluid particle position. The particle position is related to the fluid, so the velocity is always has another very important term called critical velocity. This critical velocity terms has been defined as a particular defined velocity below which the fluid shows a streamline or laminar nature in its flowing characteristics, but above the critical velocity the fluid exhibits turbulent in nature. So this particular velocity term is known as critical velocity. Now, when we are discussing about critical velocity, another term of our interest comes into play: Reynolds number. It is a very important number, and it may be called a ratio of numbers, that is, that signifies or that characterize the flowing nature of the fluid. I think you all know about viscosity. We will discuss it later in detail in the next one or two section. So viscosity is basically the drag force due to which, or the obstruction due to which, the fluid resists itself from flow. So the Reynolds number is actually the ratio of inertial force to the viscous force. So in numerator term, rho VL is actually signifying the density, that is in SI unit kilogram per meter square. Velocity will be meter per second, and since it is a length or diameter, so it will be meter in CGS. So this kilogram per meter cube will be becomes meter, since this two term is getting cancelled out, so actually it is becoming kg per second. Now in denominator, what is happening? Mu means viscous force can be defined as Pascal second. Now Pascal can be defined as Newton per meter square into second. Now this Newton term can again derived as kg meter per second square into meter square into second. So again a term has I have missed over here, that is meter. Kilogram meter per meter second will be in the numerator term, and for this part it is again becoming, meter is getting cancelled out and one second term is getting cancelled out, so it is also becoming kilogram per second meter. So this is all about the Reynolds numbers unit derivation. Now to understand the fluid characteristics, the Reynolds number is very much important. So If a fluid having a Reynolds number greater than 2000, then the fluid is considered to be turbulent in nature, and if the fluid having Reynolds number less than 2000, then the fluid is called streamline or laminar flow. Streamline flow or laminar flow fluid. So that's all. From now on, I'll be giving tips and tricks in short for your better understanding and better convenient. Thank you for watching my video. Keep on watching my lecture series. Thank you.